If you were in this room for the previous session when we were talking about honeypots. Perfect. So that sets up the stage a little bit to continue this topic around what I'm going to talk here for the next 20 minutes or so around quantum PKI and hybridization, right? So we all saw how easy was it on the DEF CON floor to set up a honeypot and then gather some data, or from her condo to gather some data. And that's exactly what you will see. This was supposed to be my slide number 4, which I kind of pulled it forward to kind of set the stage and set the tone with respect to the topic of honeypot. That kind of gave a good example of the current two very common, or I should say the most widely used threat vectors which a lot of adversaries are using with respect, kind of a honeypot kind of a scenario in an internet scale, which is harvest now, decrypt later, which many of you might have heard with respect to cybersecurity, but a much more evolving threat vector, which is essentially trust now and forge later, which is much more related to certificates. And how many of you deal or have dealt with certificates in a day-to-day life? There you go. Perfect. Right? So now, what is trust now, forge later, right? I mean, everyone knows harvesting of data, and that can be used by some of my adversaries down the line when quantum computers are, say, reality, right? Which IBM says by 2028, there should be some on the floor. But what happens is on your trust now, on your harvest now, decrypt later, it's essentially on your CIA tried, you are talking more on the confidentiality of the data. But now let's take one step ahead with respect to the integrity and authenticity of a data is when your adversaries are essentially hitting your trusted root authorities, which is your certificates, your keys, which are out there exchanging traffic on an HTTP basis, right? The claims are that if your signatures fall in the hands of the wrong adversaries, they can forge your identities and forge your systems to kind of retrieve the data out. And that's what we'll talk more about is how these two attack vectors can essentially help, right? With the help of these particular attack vectors in our heads, how can we kind of modernize our PKI infrastructure for both the web and the enterprise PKIs, which is essentially a private set of PKIs. And I am Ganesh Mallaya. I work for a company named AppUX. And essentially I do, for my day-to-day job, I work a lot with the CAB forums who kind of sets up the mandates for the certificate authorities and the browsers. And at the same time, I work with the IETFs to kind of modernize the current upcoming PQC standards with respect to signatures, which you'll see what we are working on, and obviously a lot more on the remote attestation. Right now, why is this real right now, right? I mean, we are talking about post-quantum, and you will hear more about hybridization of the PKI, right? Wherein we are talking more about how the classical algorithms and the post-quantum approved algorithms by NIST, which is FIPS 203, 4, and 5, can be merged together to make kind of a transition into the full PQC, right? Why is this real right now? And the reality of that is this is a survey which was done by ABI research company, which was in conjunction with a lot of the companies like us. The various standards board out there, right? I mean, as you could see, the CNSA 2.0 report essentially states what are those particular systems and elements within your enterprises which needs to be transitioned into your PQC and PQC reliable, phases by what years. So various standards boards like your European Unions or Indian governments, NIST, CISA from US, all of them are coming together, giving their own mandates with respect to what are these particular changes, how they have to be implemented, and how especially it was very well written in the recent publications given by NIST and CISA on the adoption of hybrid PKI or hybridization of the whole cryptography, right? And that actually brings up one of the key points in this particular graph, if you may see, is the blue curve, right? Which is essentially a trajectory of the adoption of hybridization in cryptography, wherein you will, for a foreseeable future, until maybe 2035 or 2034, there is going to be a significant uplift or significant trajectory upwards into the consumption of hybridization, where maybe it is for hybrid key exchanges, which is already in play with respect to internet, or it is hybrid, say, SSL handshakes with respect to, you may have a certificate which is having the amalgamation of both the classical algorithms and the PQ safe algorithms, right? And all of this is forced by some of this. This is essentially a nutshell of what these mandates are forced by some of these particular mandates on when a lot of these currently used algorithms, or even say hashing algorithms or signatures, are going to be deprecated. A lot of them are already. A couple of them, like RSA and elliptical curve, which is widely used today, are going to be deprecated by 2030, 2035, right? Now, we may all say, hey, quantum is right around the corner, right? How many of you, when you open your LinkedIn, right, have your feeds flooded with quantum talks? Right? I opened up LinkedIn and there was a guy called Brian C. He works for STIG, right? And he had a very similar post, which I'm going to talk right now. Is his posts are flooded with people commenting, posting, talking about, hey, that's going to come up in PQC tomorrow. This is happening in quantum tomorrow. Quantum and quantum cryptography just flooded the internet, right? Now, how accelerated are these adoptions or pilot phases going on right now? And this was a survey which was again done by ABI Research, right? And which essentially tells us 5 different pillars with respect to if you can put PKI in the mix of it, right? So today at the scale of internet, and this is one of the data which Cloudflare openly claims as well, the two of them, the first 2 points, right? A lot of your CDN providers today, be it Akamai, be it Cloudflare, even CloudFront, today I was talking to a guy from Amazon, approximately 40% of them are already PQ protected. When I say PQ protected, majority of them have either implemented PQ practices, number one, and number two, they have already implemented internet to consume hybrid key exchanges, which is at present today, as per Cloudflare, it's approximately 60% and plus as of January 1st, 2026. That is 60% and more of internet traffic. One, it is running on TLS 1.3 with hybrid key exchange, which is essentially MLChem and X25519. Now, what does that depict, right? I mean, we were all talking about, will we have PQC in implementation phases or not, right? 2026, we are seeing a lot more advanced examples of PQC and hybrid PQC or hybrid cryptography being implemented in the internet scale. Now, at the same time, there are the ecosystems of vendor, right? I mean, the biggest part of PQ migration is not just changing an algorithm, but it also is to see how my backends or how my infrastructure can support it, because inherently, the PQ algorithms are so huge that the compute, the performance, the hardware, all of has to support it and come together. So the tail end of last year and the beginning of this year, we saw a lot more vendors announcing their support for PQ algorithms and hybrid PQ algorithms. And at the same time, in the ABI research, which was done for most of the 1,000, say Fortune 100 to Fortune 500 organizations, 63% of the CISOs suggested and said that PKI innovations or PKI, say, modernizing their PKI is one of their new board level talks to see how they can establish their root of trust to be one of their main element from the PQ journey. Now, that brings up why PKI, right, essentially is the board level topic. That goes back to the 5 topics which essentially is going around in and around the market right now. One, definitely certificates have been chaos for everyone, right? Whoever deals with it, you know how many certificates you may have, renewing them, revoking them, deploying them to the endpoint, maybe sometimes in CI/CD pipelines, it's a chaos, right? And we have seen examples of one certificate expired, oh my God, the entire company now runs around to figure out why it has expired, all the drills, right? And at the same time, around last year, I think it was April or so, the CAP forum came down, drilling down on the validities of these particular certificates, coming down from 393 to 47 by the end of 2029, and the first string data starts on March 16 this year to 200, which means I cannot still rely on my Excel sheets. I need to have a repeatable process to ensure these certificates can be renewed, deployed efficiently. That's the fifth point, essentially, the crypto agility, right? And at the same time, I have a really good friend who used to work for SailPoint, right? And all that. And he said one thing: the space of IAM, identity access management, specifically with respect to identities and certificates, have evolved so fast and so much in the last 2.5 years that it did not evolve in last a decade or so. So today, pretty much everything we touch from an identity space has something or the other to do with an SSL certificate. Now, be it a user authentication, MTLS, site-to-site VPNs, Zscalers, all these vendors have something to do with your certificates to be deployed, which means much more added workload on top of your head to ensure that when the PQC hits the floor, you need to ensure the root of trust is secured and have a repeatable process to ensure it can be renewed. And at the same time, all these government agencies or regulators are mandating various changes to be implemented for their respective countries at the same time. And all of this comes down to, and this is well written in the NIST documentation, is the crypto agility path. And again, it's not an end state. It's a milestone number one. Right? Crypto agility, it's not an end state. It's kind of a myth. Everyone thinks that, okay, if I can have everything automated, I'm on a crypto agile path. It is not. It's a milestone everyone essentially goes through. Now, what is really the path, right? When you talk about enterprise PKI, right, and when you talk about web PKI for your public trust, what is really the path with respect to enterprise PKI we can adopt today, right? And if people are following the IETF forums, which essentially defines you a lot of standards with respect to signatures and all that, and one of the most spoken and most controversial talk track which has been there in last 1.5 years is what is the hybrid certificates or composite certificates. Now, what do we know about composite certificates, right? So today you have a certificate which can be signed by elliptical curve or an RSA, right? Which is a single signature certificate, goes onto your internet. It's barely 2,000 bytes. Internet takes it like a piece of cake and then handshakes it. Now, come to PQC cert, which is on the top there, like MLDS 87, the biggest of the lot. The key size starts in around 16,000 bytes. Right? So that's a huge thing, and then you will see the performance dips. The TCP segments will start dropping packets anything beyond 11K bytes. So what happens here in composite certificate? Now, the primary reason why a lot of these engineers, I mean, this is an IETF draft. If you open towards the bottom, you see the link of it, right? The primary reason why there was a conversation for composite, and composite is not a new topic if you are a cryptographer. It's not a new topic. It has existed for ages, but it has evolved in the last 3 years or so to make much more sense with respect to PQC, because there needs to be backward compatibility. Right? When you switch over to PQC, your current TCP cannot take the load, number one, and number two, with majority of our traffic running still on TLS 1.2, TLS 1.2 can't take PQC either. So now, which means I need to switch over to TLS 1.3 with PQC, for which half of the internet, or I should say 90% of the internet, is still not ready for. Now, how do I ensure that I can protect my data at the same time have a backward compatibility that all my applications can still run smoothly? That's where the composite certificate was really born, right? Now, the real advantage here is if you see on the, if you see over here, that's a signature which we are talking really about. So today, if you open up a certificate, you will essentially see RSA 2048, say RSA 4096, etc. So today, with the composites signatures, we are really talking about both the PQC and RSA or elliptical curve sitting together as a single signature within a certificate without breaking how your SSL handshake and TCP kind of understands the signature handshake today. So this was, Cloudflare and Google were kind of very generous enough to give us the labs to kind of test the theory from what we were trying to do with the IETF. And this was well tested. And right now, I don't know how many of you followed Google yesterday. They kind of dropped a bomb right where we were here talking about, say, AI. They kind of dropped a huge bomb on how they are modernizing the web PKI with something called as a Markle tree certificate, which actually follows these particular signatures, right? So these particular signatures kind of give you three different benefits to begin with, right? The number one is it secures your data because you are, even though RSA is broken tomorrow morning, you are still having your certificates and your data essentially signed with an additional signature, which is PQ safe. Mathematically, yes. When quantum computers hit, we don't know if FIPS 2, 3, 4, and 5 will still be viable, or the second round, NIST is going through second round of evaluations of signatures as well at the same time. And the second thing is you don't need to lift and shift and build every application ground up to ensure that you can support PQC algorithm, because the composite signatures allows you a huge backward compatibility. So even though you're running an Apache application, say in a login page running today, the adoption of these particular signatures allows those particular applications to run on the web without having to have you to write additional codes for backward compatibility. But yes, it has to be on TLS 1.2. But when you go to full PQC, it needs to be TLS 1.3, which means that needs to be an upgrade. So it gives you a runway with respect to making those particular changes. Obviously, a lot of those changes do hit the market by 2030, 2035. So you get enough runway to do it, right? Now, this composite signatures are essentially a migration bridge. It is not your end state, right? And everyone who did work on this draft, along with NIST and every other bodies, we did understand the downside of it. It is a migration bridge, right? And this migration bridge allows essentially kind of gives you a visual comparison. Now, this is essentially we kind of tried to build it, right? So you can imagine that we kind of drew it on a whiteboard and tried to give it to the AI to kind of build it. Some of the data is not really very accurate here. But what you will see very clearly in this is when you see the classical handshake, what you're seeing today, right? When you open up an application and try to handshake it, the TLS handshake, the way it is built, understands only one signature, right? Which means you send it RSA or elliptical curve, it understands it, does a client hello, bye-bye, and all that, and sends and transacts the data. Now, there is one more element in TCP, right, which we kind of forget, is the key size or the signature size, right? Now, today, when you do elliptical curve, which is the biggest one, you will see the max of 4K bytes, right? That's the max the TCP will see from an SSL certificates today. But when you do MLDSA, the third column, the beginning is 13 point and change, which I'll show you the next one, which means your page takes forever to kind of load. And this was tested with a lot of test labs with a very basic login page to kind of load on a Google browser. It takes a lot of time to load. So without having to have a lot of change, one, on your application, and number two, on the TCP header, it was very difficult to load a pure PQ certificate. But when we brought in the composite, which is this middle tier, yes, there needed to be certain level of changes to be done on the application layer so that we could put in the composite signature, because by default, not all the systems do understand these particular signatures. But without making significant amount of changes, the TLS handshake was smooth enough, right? Yes, the key sizes were still huge enough. They were 9x larger than your standard RSA, the baseline RSA. That is 2048, but they still allowed us to do the necessary handshake and say transaction of the data from one server to another without having to have any issues, because at the same time you're getting an RSA cert and also a quantum resistible, so that no man in the middle can essentially come in between and get the data out, right? And this is the comparison which we were talking about. So today, if you look at the classical baseline RSA, which is 1664 bytes, that's the baseline RSA, right? That's when you create a certificate, that's the baseline data which gets out. And if you go to the bottom of it, that's the full PQC chain, that's 13x larger than your current chain. 13x larger, and the tipping point of the TCP segment is at 11K. So anything beyond 11K bytes on your TCP segment, the segments start dropping on the performance and the packets at the same time. The composites, or you could the world knows it by hybrid, by the way. Hybrid certificate, you might have heard of it. There's 8x to 9x larger depending on the algorithm you're selecting. In this case, we took MLDSS 65, but in the previous example, you might have seen it was MLDSS 87. So if you take 65 to 87, there's a minor change in between the key sizes. But it is still, yes, when compared to RSA, it is 9x larger, but still cuts down your complete performance by 30% with respect to PQC. And that's what we did it in the Cloudflare's and Google's lab. Now there are few more companies from a production scale perspective trying to implement this from a pilot stages. So what you would see is in the breakage zone, right? If you do it from a TLS handshake, from a breakage zone perspective for both the compact and performance cliffs, there was a drop of approximate at the 11 kilobytes or the 11K bytes range is where the performance start dropping today. And the composites was somewhere around 10K-ish, right? With the top tier signature of MLDSA 87. The whole signature was still, say, under 11K, let me put it that way, right? And if you do take segments of TCP, your composite was still 8 segments versus your full PQC is 11 and 11.5 segments, which is still higher with respect to TCP because TCP breaks anything after 11, right? And obviously, there were much more, say, advancements with respect to bandwidth consumption, which is much more important for telecom sector on how the bandwidth is being consumed and how the bandwidth is given out and given in. So that was essentially an overall advantages with respect to 30% of the whole transaction was much more smaller when compared to the full PQ chain, right? Now, these are all some of the, I wouldn't, except for the first block, these are very common to know who are doing what. If you go just Google around the collaboration between Cloudflare and Google with respect to hybridization, you will see a ton of data with respect to two things. One is composite certificates, another is Markle tree certificate, which is an adoption of hybridization in the web PKI. So the whole contention is the way the PQC was evolved or has evolved, the internet is not going to adopt it as is or cannot adopt it as is. The browsers cannot do it as is. So there is a much more advanced way of how you can modernize the whole PKI with respect to something called as Markle tree. Now Markle tree is again a not new concept. It was born in 1974. So they are adopting that into the world of PKI to see how that can be implemented. It's again an IATF draft, so please feel free to go and read about it, what it does. And again, the same composite certificate, it is running in GitHub repositories already. There are GitHub repo codes of how the composite signatures are used and developed. And at the same time, there are two of the MANG companies. Obviously, one I've already said it, it's Google. There are two of the MANG companies who are implementing in a pilot stage on how these composite certificates could be used for their PQR, that is post-quantum readiness program, for their own internal infrastructure. Same goes with two of the three telecoms. One happens to be in Seattle. And obviously, all of these are pilot people who are advancing and collaborating with the IETF and NIST to kind of test these particular frameworks to build out some baselines. So yes, it is signed twice. This is not very common for the certificates to be known for, that a certificate is signed twice with two different algorithms. But it is a step towards having much more secure data and transaction with respect to not doing anything between now and tomorrow whenever the CQRC is much more relevant, right? And then there are 4 pillars with respect to implementation of this. This is something which this is an evolving document with NIST as well, but these are the 4 pillars which we are working through. Obviously, with PQC, everyone would have heard auditing an inventory, right? Let's build an inventory, let's build an inventory, let's build an inventory. Yes, the same happens for PKI too, right? If you want to move away into an hybridized model, inventory is one of the key things to know what are those particular certificates you need to inventorize. Start with your internal PKI to begin with. Number 2, The time is gone. This particular slide was built last year for a different talk, right? So the time for pilot has already started. These signatures are already live. They are already there, available in various crypto libraries. I can name a few. They are already registered in IANA databases, which are referred by these browsers to kind of understand the signatures and then evolve through them. So these signatures are already live for people to test it, and there are various larger organizations already testing and implementing this. But with these advancements in signatures and PQC comes one of the key important point with respect to today's practices of PKI is today's CPS standards. People who deal with certificates and PKI would know this really, really well. They're outdated. Right? They need a lot of evolution with respect to see, with AI coming into picture, how can my PKI be on the brink of not breaking on its own, right? So CPS standards, yes, they are evolving. There are various PKI companies which offer both the web trust and the internal trust certificates. They are working towards modernizing how you can deploy much more simpler PKI, number one, and much more stronger PKI practices. Again, it's an active project going within IATF, so please do follow a group called PLANTS, PLANTS. It's not a great name for a IATF working group, but PLANTS, it stands for PKI and various things with respect to certificate transparency and whatnot. And I call this as a migration, but I also don't like the because it's really not a migration, it's a transition from point A to point B. And the point B for us is to get to a PQ ready state. But there is a point A, point 5, which is where we are going to, which is the hybridization model, because you cannot go full PQC today, which means it's really not a migration. It's a transition phase which has to ensure you have a lot more accountability with respect to backward compatibility, right? So today's applications are built in such a way that it runs on the classical algorithms. Yes, that's the world we live in. But as we move towards a quantum ready state, these applications for today's success, they need to be backward compatible, which is where the hybrid model do come into picture. And for hybrid model to work, we have to ensure the backend infrastructure of that is not toggled with too much. And again, these standardizations are essential. This is one of the posts which I really liked yesterday, is that we are talking about PQC today, but tomorrow, the security field is evolving, or cybersecurity is evolving so much on a daily basis. We might not even know there might be a post-quantum state also, right? We don't know. That's the reason why the backward compatibility and crypto agility, these two states are very, very key important. That's where this thing come into picture, right? We can build anything which to sustain PQC or classical or post, right? But for every migration or transition, if we were to re-architect, redeploy everything from the scratch, it's not sustainable. And with AI coming into picture, God knows what will happen, right? So the crypto agility state defines one of the key elements of it is to have everything defined in such a way, yes, from start to the end, define it in such a way it can be repeatable, but at the same time, they are backward compatible, which means you don't have to rip and replace all these key elements for them to work, right? And that kind of sums up my talk. I'll just open up for any questions if you guys have. I know I think, right on time? Yeah. Yes.
How is a double signed key smaller than a traditional post-quantum transfer?
So yeah, so it's a good question. How are they smaller than a traditional quantum? Is because of the concatenation process used in creating those particular signatures. So you're not creating a signature separately. So if you open up the databases and see how these signatures are built, it's one signature, right? So they are concatenated together in such a way that they in nutshell create a smaller key length. All right. Yep.
Yeah. Great talk, by the way.
Thank you.
The only question I have is about the end, where you're saying that, let's say there's going to, by the point between the backward compatibility and the transition phase, that there might be another jump in between that. What if the jump is beyond what we're designing for at that point? Is it back to square one?
Again, yes, that's essentially how things have to be defined. Again, we don't know what's going to be happening by 2035. right? That's where everything is supposed to be deprecated. We don't know what's going to happen between today and 2035. So that's the reason why a lot of these particular states are talking about having backward compatibility baked into the platform itself.
Okay. Cool.
Thank you.